Okay.
I know, seriously.
What is cosine x or y?
X.
Cosine is x. So pi over 6 is which one of these angles?
X. None of them.
I
No
don't
X.
remember now.
There's no 6. There's
No, dude.
It's that one, sussy.
Okay, get out.
All right. You should be able to fill in the rest of them real quick.
Is that a 3?
Is your bottom one a 3 over 3?
Yep.
Thank you.
See, thank you for answering the question. I just looked really stupid trying to zoom in my eyeballs.
I literally thought it was like a school.
I was correct though.
That is the only other one I've done was actually correct.
Okay. There's a reason why I'm having you put this on here because we're going to need it again. So we're going back to using the unit circle.
Brothers.
So but today because anything we need is going to be on this table, on this chart, so you can use the chart for today. All right, so we're going to find ways. So yesterday we talked about Monty the cat, and we used our calculator, or we used Desmos to find our solutions. So I want to use Desmos again. They have put up the picture of what it looks like. We want the actual values, so I want us to put Desmos up again. So if you don't, if you have your Chromebook out, get it out, and so we can put this into Desmos, so that we can figure out what x1, x2, x3, and x4 are. So let me see. So the equation that they gave me, cosine x equals -1/2. Instead of putting it in as two separate lines, cosine x and then -1/2, I just moved the -1/2 over so that we could kind of do it like we did yesterday. So I took that and moved it to the other side. So I typed into Desmos y equals cosine of x plus 1/2, or plus 0.5 is what I did, because they called it 0.5 right there. Is everybody okay with that? That way I'm only having to type in one thing, because we talked about yesterday, it's kind of cumbersome for me to type on this. Just use your type one line. And then it drew for me a picture that matches the picture that they have right here.
Oh, nice.
So I just need to identify, if you see where x1 is the first dot to the left of the y-axis. So that's the first one that I want. So this value right here. And when you click on that, it gives me the x value is -2 pi over 3. So x1 is -2 pi over 3. Is everybody okay? Y'all following so far? Got it on your Desmos and everything?
Yep.
All right, and then I can find x2. So I'm going to click on the next dot. What's identified as x2 on their drawing is 2 pi over 3. And then there's x3.
Is that not the same thing?
Which one?
Okay, x1 and x2 are the same thing.
X1 and x2. So x1 is a coming out of this Monty, or this is our dolphin. This is the dolphin coming out of the water on x1, and then going back in the water on x2.
So it's the same coordinate point. Just go.
Well, one of them's negative because it's on the left of the. But so.
Yeah, I see that.
Because you can't jump up and jump right back in.
Yeah.
No, I got you.
And then x3 is now I've got another coming out of the water at 4 pi over 3. And then I have x4.
-4 pi over 3.
8.
It's 8 pi over 3.
Because now I keep going right according to my drawing.
Yeah.
And x5 10 pi over 3. All right, now, I'm done with Desmos for right now, so I'm going to get rid of that for just a second. Oops, I didn't mean to do that. All right. All right, so now I have found all of my values and solutions that are on the screen. But you remember, I mean, I could back this up and go to the left, and there's more answers going this way. I have infinite answers, and I have infinite answers going this way too. All I found were the 5 that they identified on the picture. So we're going to talk more about finding more of them in just a minute. Okay, so that's how we did it yesterday, using Desmos. It's a great way to do it, but it's not the only way to do it, and it's not the only way that we need to know how to do it. So the second thing we can do is we can solve it algebraically, which you guys have already done. We've done this before. So that's just to get x by itself. So if you look, I've got the equation written right here, cosine x equals negative 1/2. And I just got to get x by itself. So I got to get rid of the word cosine. So in order to do that, remember we do arc cosine or inverse cosine, cosine to the negative 1. And that cancels the cosines on the left, and it leaves me cosine to the negative 1 of negative 1/2. Okay, so now, we're not using our calculator for this, because the calculator is going to give me nasty decimals, and I don't want nasty decimals. Instead, I'm going to use the unit circle. I'm going to use the chart that we created at the beginning. So the first thing I need to ask myself is, for what reference angle is cosine equal to 1/2? So you can look at the top of the page. Where does cosine equal 1/2? At pi over 3. Cosine is 1/2 at pi over 3. You just look at the table that we just filled in, right? But then the next question is, the problem actually though had negative 1/2. So what quadrants is cosine negative in? 2 and 2 and 3. All right, so that means I need the pi over 3's that are in quadrant 2 and 3. So think about it for just a minute. If this is pi, that means it's also 3 pi over 3. So if I back up into quadrant 2, what is this? 2 pi over 3. So 2 pi over 3 is one of them. And I also, so this is 3 pi over 3 right here, I also need to go down into quadrant 3. 4 pi over 3. So now, we already found those solutions when we did it on Desmos. It's asking me which ones do they match with? 2 pi over 3 is which one?
X2.
X2.
And then X3.
X2 and X3. Okay, so real quick, let's look at X2 and X3. I just want you to think about it in terms of Monty the Cat. X2 is a going in the water solution, and X3 is a coming out of the water solution. So I have one of each, an in the water and an out of the water. You need to have that. Anytime you have a sine wave or a cosine wave, you have to have two solutions because you need one that's going in the water and one that's coming out of the water. I could get a different one. I could have gotten X1 and X2. That's a coming out and a going in. And that works too, but you just have to have one of each. Okay, and then it says explain how to find the other solutions. So if I've got X2 and X3, if I want to find X4 and X5, if I want to go from here to here, a going in the water to another going in the water, what do I have to do to get to that?
Go a full circle.
I do. Go a full circle, which is a what? What do we call that?
2 pi.
2 pi. You have to go a full period, which is 2 pi. So how to get the other solutions? You just add 2 pi. What if I wanted to back up and get the one over here?
Subtract 2 pi.
Subtract 2 pi. Good. Okay. Are y'all okay so far? Kinda? Okay. All right, so we want to generalize the solutions to represent the infinite number of possibilities. So let me write my solutions real quick. the ones that we got, not from the calculator, but the ones that we got when we did it by hand, we got 2 pi over 3 and 4 pi over 3. So I had a going in the water and a coming out of the water. And then we just said, if I add 2 pi, or I add a period to those, that will give me the next 2. And what happens if I want to get the next 2 after that? So that gave me 4 and 5. What if I want 6 and 7? What do I do? Add 4 pi. So you add 2 pi, you add 2 pi again. You add 2 pi again. You just keep adding 2 pi as many times as you want. And the way we represent that is by putting a little n next to the 2 pi. That n just means you can do it as many number of times as you want to. You can add 2 pi once, you can add it twice, you can add 3 times, you can add as many times as you want. That's a generalized solution for infinite positives. Okay, so now I want you to think, and I know this is when all of the things that we started learning about trig all kind of come back together. So we learned, this is a while back, we learned that when if we are using our calculator and I'm doing solving like this and I use arc cosine or whatever, my calculator's only going to give me one answer, remember? But there are 2. There's at least 2, but there's more than that. And I need to figure out, how do I get the other one? So if you remember, we had a little chart that we could look at that would tell us how to find cosine, the second answer for cosine, how to find the second answer for sine. Well, if you remember, the rule for cosine is whatever you got as your first solution, you can just make it negative. So if you look at the picture on the front, my first solution that I got, I did not mean to do that. Okay, hold on. I guess it won't let me do it because I'm recording, I guess. Okay, never mind. My first solution that I got was 2 pi over 3, and that was x2. So if I just make it negative, so that was this one, that's the one I got first. If I just make it negative, it gives me this one. And that means I still have a going in the water and a coming back out of the water solution. So you can just make it negative and get both, instead of using the next one we found, which was 4 pi over 3. Either way works, so you can do it either way, but just know that that same rule applies that we used earlier in the year. Okay, so and I'm just going to say, because the rule for cosine, the reason that this works is just to make the solution negative. Now, that is not the rule for sine. The rule for sine, if you remember, is pi minus. Pi minus whatever the calculator gave you. Pi minus the first solution that you found. So we're going to do a sine one now. So we're going to solve it algebraically. So that just means all the rules of algebra apply. I'm trying to get x by itself. So if this was my problem right here, what should I do to get x by itself first? Divide by 2. So now I have sine x equals square root 2 over 2. Still trying to get x by itself, and so I need to get rid of the word sine. So arc sine. Alright, so now I have x equals arc sine of square root 2 over 2. So that means, part B, what reference angle has sine equal to square root 2 of 2? Look on the chart on the front page. Or use your left hand. Figure it out.
That's not what it says.
Pi over 4. Alright? Well, in which quadrants is sine positive? Because it's positive square root of 2 over 2. So which 2 quadrants is sine positive? 1 and 2. Alright, so pi over 4 is in quadrant 1, so I have that solution. the pi over 4 in quadrant 2? So that's 4 pi over 4. So what's this? 3 pi over 4. Okay, well that gives me my first two solutions. It gives me a going in the water solution and a coming out of the water solution. I need the next two. How am I going to get those? Add 2 pi. We're going to generalize them just like we did the others. So I can do x equals pi over 4 plus 2 pi n, or x equals 3 pi over 4 plus 2 pi n. Now, the first solution I found was pi over 4. And the rule for sine is pi minus the first solution that you found. Well, what is pi minus a quarter pi? Three-quarter pi. That's my other solution. So now we found it just by going around the unit circle, but you could have found it the other way. It's just two ways of doing the same thing. So that's what this question G is asking. How are the two solutions found using the inverse sign related by pi? The second solution is pi minus the first, because that's the rule for sine. So the rule for cosine was make it negative. The rule for sine was pi minus. Now think about this for just a second, because this is where I think things start to make a little bit more sense, where that little chart is concerned. So for Monty the cat, we had go in for sine and cosine for the circle going round and round and round. We have go in the water, come out, go in the water, come out, go in the water, come out. But for tangent, what happens to Monty the cat? He only comes out. That's it. So do you need two solutions?
No.
Nope. You only need one. So for tangent, I'm not going to have a rule like this because I don't need it. I only need Monty the cat comes out. That's all. All right, so because we're about to do tangent, so let's go ahead and solve our tangent problem. What should I do first? Divide by -3. So I have tangent of x equals negative square root 3 over 3. Get rid of tan by arctangent. All right, so now tangent, I have them memorized, but just go look at the chart. Where does tangent equal square root of 3 over 3? Pi over 6. But I need it where it's negative. In what quadrants is tangent negative?
3 and 4.
Close. So remember, that's where they're positive. And I want to know where is tangent negative.
So it would just be 2.
2 and 4. All right, so that means I need the pi over 6s that are in quadrant 2 and in quadrant 4. So take a second. I want you to think about it.
Ooh, that's line right there.
See?
All right, now, if all the way to here is pi, that means this is 6 pi over 6. So I need to back up. So what would the one in quadrant 2 be? 5 pi over 6. Now, I will say this. For tangent, we only need one. That's the only one you need. But let's just, because we already said that it's quadrant 2 and quadrant 4, let's go ahead and find quadrant 4. So if I go all the way around again, that means this is 2 pi, which is 12 pi over 6. So if I back up to quadrant 4, it's 11 pi over 6. All right. Okay, so now this is the only thing where we do have to be a little bit careful, because now I have Monty the cat flies out of the water, and then Monty the cat flies out of the water again. How often when it's tangent?
Every pi.
Close. It's every pi.
Oh.
So remember, it's half of what sine and cosine are. The period for tangent is just pi. So to find all the other solutions, you would just add pi, which is the period. So I'm going to say add the period, which is pi. And you can see why I only needed one solution. Because if you think about that for just a second, if my first solution was 5 pi over 6 and I add pi to it, you get 11 pi over 6. You get the next one. So generalizing my solutions is going to look just like before, except for I'm not adding 2 pi, I'm just adding pi. So it would be 5 pi over 6 plus pi n. That could give me all the solutions. And do you need both solutions in order to represent the infinite? No. Tangent only needs one. Here's the little chart again. Same chart that we used before. This tells us how to get our general solutions, though, that they've just added in the 2 pi n for us. But you can see for cosine, now look, I don't want to confuse anybody, but you can do what we just did. Find the 2, because there's always a solution in each quadrant. You can find the 2 solutions that way, and then you don't even need the little chart. Or you can find one solution and then make it negative. And that'll work too. Either way works. Same thing for sine. You can find the 2 from the unit circle, and those are your 2 solutions, and you just add 2 pi n. Or you can find the first one and do pi minus and get the second one. Either way works. And then tangent, you only need 1. So, all right. So what you're going to do, I will do 1 or 2 more with you, and then you can do the rest of them. So let's do, I'll do A with you on number 5. So we're solving for x. So my first move is to divide by 2. So I have cosine x is negative square root 3 over 2. And then I'm going to inverse cosine or arc cosine that. So I need to figure out, where is cosine equal to square root 3 over 2? So you can flip back to your chart on the front if you need to do that and find where your x value, or where cosine is square root of 3 over 2 at the pi over 6 is. Then I need to consider, okay, but it's negative, so I need to know what quadrant is cosine negative in.
Couldn't you just put on the first part?
So which quadrant is cosine negative in?
4? No.
It's positive in 4.
Oh, so it'd be
2 and 3. So I need the pi over 6 that's in quadrant 2. What pi over 6 is in quadrant 2? 5 pi over 6. And I can add 2 pi in. Now, I could just make that negative, because this is cosine, and do negative 5 pi over 6 plus 2 pi in. Or I can go, cosine is also negative in quadrant 3, which would be 7 pi over 6. So either one is fine. However you want to do it is fine with me.
Definitely the first option. Much easier.
All right, I'll do one more with you. Which one do you want me to do? A tangent one? Okay, let's do C. So I need to get x by itself. So I'm going to divide by negative 1. So that gives me tan x equals negative square root 3 I've got to get x by itself. So in order to get rid of the word tangent, I have to inverse tangent. So now I'm asking myself, where does tangent equal square root 3? So I can go back to my chart and look. Where does tangent equal square root 3? Pi over 3, but it's negative. So I need to know what quadrant is tangent negative in. It's positive in quadrant 3. It's in 2 and 4. It doesn't matter which one you use. So I'm going to do the pi over 3 that's in quadrant 2. What's the pi over 3 in quadrant 2? 2 pi over 3. And tangent only needs one solution, so that's all I need. 2 pi over 3 plus my period is pi in. So you add in pi in right there. All right? Y'all okay? All right.
Naturally or physically?